All right, welcome to the Algebra 2 final practice exam. This is the first version of it, but the third video that I'm making. Remember this right here, let me grab the purple pen. This right here means the last answer. So it's the last answer plus 2, the last answer plus 2, the last answer plus 2. So it's 6, 8, 10, and 12. So f of 1 tells you the first term's 4, which is already there for you. And then you start ka-chunking out the sequence with the second term, third term, fourth term, fifth term. So that's why you do that. All right, so this one here is like in the form AB to the x. Right there is your growth factor. So 1.2 means 1.20, which means 20% more. So you're basically just multiplying by 1.2 a bunch of times. So 1, 2, 3, 4, 5, n equals 5, n equals 4, 3, 2, 1. So the explicit formula allows you to jump anywhere you want to. So you could just put 5 in here and jump right to the fifth term. But the easiest thing to do is just to go ahead and multiply by 1.2. So you're starting off with 2 times 1.2, enter, 2.4 times 1.2, enter, and then times 1.2 times 1.2. So I'm going to write all these down there. So you just keep multiplying by 1.2 over and over again. So it's 2.4, 2.88, 3.456. That's a very satisfying number. And 4.1472. So you're multiplying by 1.2. The n minus 1 means you're not multiplying by 1.2 to create the first term. You're multiplying by 1.2 to create the second term. So you have to do an n minus 1, not just n. And that's where we're going to do this problem here. We're going to use that n minus 1 idea to write these explicit formulas. So to go from here to here, you are adding 4, and that's going to be thought of as arithmetic, right? That's adding 4. To go from here to here, you're multiplying by 3. So you're doing times 3. And so there's times 3 and then add 4, the two ways to do this. You want the explicit formula. So f of n is equal to, we're adding 4 a whole bunch of times. We're not adding 4 in the beginning, so we do n minus 1. And we're adding 4 to the first original starting point, which is 2. So 2 is your starting point. You're adding 4 a bunch of times. So you do n minus 1 because you're not adding to make the 2, you're adding 4 to make the second term, which is 6. Then we do f of 140, which means you're not adding 140 times 4, you're doing 139 of them. So 139 4s are being added to 2 to make the number in the sequence. So we got to multiply this out. 4 times 139 plus 2 equals 558. So again, you're not adding 440 4s, you're adding one less, 139 4s to the initial term of 2. Okay, now we're going to think about as multiplication. This is like AB to the x, so your starting amount is 2. We said that we were tripling it, so it's 3 times as much. And we don't multiply by 3 to make the first term, we use it to make the second term, so we do n minus 1, f of n, and then we do the 15th term. So again, you're multiplying by 3, not 15 times to make the 15th term, you're doing it 14 times. So you put in the n is 15 there. So then we type this into the calculator, 2 times 3 to the power of 14, which is 9,565,938. 9,565,938. Okay. Here are the dots. We have these dots here. And we notice that for step 2, we're adding 2. For step 3, we're adding 3. For step 4, we're adding 4. So we're adding the step number every time. So it's the previous term, which is n minus 1. And then you're just adding in whatever the step number is. So if the step number is 4, you add 4. If the step number is 5, you add 5. So that's the formula. And we do this starting with n is 2. because you've defined the first term and then you're adding the step number every time. Number 5, we do zero product proper super t. So we set each factor equal to 0. And we're going to subtract the 4 over, so x is equal to negative 4. We add the 8 over, x is equal to 8. And then we add the 5 over, so we get 3x is equal to 5. And then we have to divide by the 3 to get x by itself, so it's 5/3. So my answers are 5/3, negative 4, and 8. All right, so there's that one. Number 6, now we have to do the polynomial long division. So we make our division situation here. So we got 7x squared, 14x plus 8. And we're dividing this up so that we can make it look like question number 5. So here it is in standard form. This is a polynomial in factored form. When it's in factored form, it's easy to set the factors equal to 0. All right, so this is where we make it the same. We subtract it, and then we drop down and we make it the same, we subtract it out. So by making it the same, we need to make an x cubed. I already have an x, so I need an x squared. So this times this is x cubed. Why do I want it to be the same? So when I subtract it, it becomes a 0. This times this is 2x squared. I pick up the red pen. This is the old pick up the red pen problem. Subtract, subtract. That goes away. This becomes 5x squared plus, drop the next thing down like you do in long division. Okay, now we need a 5 and an x. 5 times x is 5x squared. 5 times 2, 10x. Draw the line. Subtract. These are the same, so when I subtract it, it goes away. 4x. Drop the 8 down. Now we need a 4. This times this is 4x. This times this is 8. We subtract it, and I get 0. My remainder is 0. So now we know that p of x is x plus 2 times this answer up here, which is x squared plus 5x plus 4. We're going to make it be linear factors, so we have to split it up one more time. So plus 4 and plus 1 is how this factors. Now we have this factored into 3 linear factors. Now we're going to find the x-intercepts. So these questions go together. So when it is factored, you get x-intercepts. When you have it in this form here, when it's in this form. So now we have the x-intercepts by factoring. So we set each factor, or we got to factor it first, then we set each factor equal to 0. And 6 and 1 would make the 7 if these are both negative. So we do zero product proper t, and we get each factor equal to 0. So we get 6, and I get x is 1 by adding those over. Okay, we love our binomials, so we're going to put our binomials in parentheses. We cross multiply. 6 times this is 6 times x plus 3. 2 times this is 2 times x minus 8. So now I can distribute through the parentheses. 6 times x, 6 times 3, 2 times x, 2 times the negative 8, or minus 8. So it's 6x plus 18 is equal to 2x minus 16. I always say move the smaller amount of x, so we're moving over the 2x. So we get 4x plus 18 is equal to negative drops down, negative 16. Then I move this 18 by subtracting it over, and I get 4x is equal to negative 34. Unfortunately, 4 doesn't go into 34 evenly, so it would be negative 8.5, negative 8.5, negative 8.5, or you could have negative 17 halves as an answer. Okay, next question is finding or using the rule. When you multiply like bases, you add the exponents. When you multiply like bases, you add the exponents. So 8 plus x is equal to 3. That plus that is equal to that, since the bases are the same. So x has to be a negative number, so negative 5. When you have squaring, to get rid of squaring, we square each side. So we get 2x is equal to 8 times 8, which is 64. Not 16, it's 64. So squaring, square rooting are opposites of each other, so I square both sides. So divide by 2, x is equal to 32. All right, now we're going to solve by factoring, and what we do is we have x and x, and then the 60 has to be broken up to make 16. So it's solved by factoring, which is also the same thing as finding the x-intercepts. So we've really already done this problem. 6 and 10. All right, and then we have x plus 6 is equal to 0, x plus 10 is equal to 0. Minus 6, we get x is equal to negative 6. Subtract the 10 over, x is equal to negative 10. For the quadratic formula, a x squared plus bx plus c is equal to 0. Now, a goes with the 3, so a is equal to 3. B, there's a invisible 1 there, so b is negative 1, and c matches with 3. So it's 3, negative 1, and 3. These go into the formula. So x is equal to negative b, but b is already negative, so that double negative makes it positive, plus or minus square root over 2a. Well, 2 times 3, right? 2 times 3 is 6. So then baby parentheses, b squared minus 4 times a, which is 3, times c, which is 3. Now, put it in exactly like this. I always color this green. So we make this green here. And this is what you put in the calculator. Not the square root part, just the part underneath, because it's the square root of b squared minus 4ac. If you type it in exactly as I showed you with a left parenthesis, negative 1 quantity squared, whoops, I have a double parenthesis, left parenthesis, negative 1 quantity squared, and then minus 4 baby parentheses in a 3, and then another baby parentheses with a 3. So it looks exactly like what I wrote there. No square root, just the green part. And I get negative 35. So x is equal to 1 plus or minus the square root of negative 35 over 6. So this doesn't factor, that's why we do the quadratic formula, and 1 plus or minus. Now the negative comes out to the front, so we get, because the negative square root can't do it, so that's an imaginary solution, and then the square root of negative 1 is the I, 35 over 6. So that's what we do for that one. All right, now we're doing some exponential stuff here. We have a $75,000 home. So it's A, that's your starting amount. And B, growth rate, 2%. Don't put a 2 there because that means doubling. 2 pennies more. So 2 pennies on the dollar. And we're doing that from 0 to 9. So we're doing that 9 times for 9 years, from 1990 to 1999. And we just want to know the value of the home. So y equals, we type that into the calculator. So it's a $75,000 home, and we're doing 2% more for 9 years in a row. And it's up to 89,000. So it's 631.94. That's an approximate value. All right. A, B to the X. So starting amount, 2% more, and then 9 years. If it was 2% less, B equals 0.98. That'd be 2% less. I don't want 2% less, right? I want 2 pennies more. So it's added to the dollar. So log base 3, right, of 81 equals 4. So what is this? This is the base. This is the answer to the problem, and then the exponent is what comes out. So when you do a log problem, your thing that comes out of it is always an exponent. So 3 to the 4th power is 81. So remember, logarithms are bay before anyone else. Okay, number 15, we have to come up with an exact answer for this and a decimal approximation of 3 decimal points. All right, there's multiplication in them thar hills, so we divide to get rid of the 7. So we have 5 to the x power, 5 to the x power is equal to 100. Now, I know the answer is 2 something because 5 squared is 25. 5 to the third power is 125. So 2 is too small, 3 is too large, so it's 2 point something. So how do you get the exact answer? Well, you bay it up. Log base goes first, so that's your base. Answer, 100, equals x. So that's what x is. X is log base 5 of 100. Now, I have to come up with a decimal approximation. So x is approximately equal to, I go where? I go to the math menu, and I go up arrow, up arrow, up arrow, and I choose the log base button, and I put in a 5, and I put in a 100. Enter. So I told you it was 2 something. It's 2.861. 2.861. Log base 5 of 100. Ba-dum-ba-dum-ba-ding. So exact answer and approximate answer. Okay, number 16. This is when you have E, you're talking about populations of things that are alive, like people, bacteria, crabgrass, I don't know. It's just stuff that's alive. So this is not 12.5 people, it's 12.5 thousand people. That's your starting population. So it's 12,500 people. That's what it's saying. The growth rate for an E problem doesn't have to have a 1. So that 3 right there means 3% more. You do not have to have the 1. It's not 1.03. 1.03 would be for the other exponential model. But this, for E, it's included in that, so you don't have to have it. And then we're going to go to 25,000. So to go to 25,000, we get rid of the thousands, and we just say 25, which means 25,000. So we do 12.5 E to the 0.03 T is equal to 25, which means 25,000 because that means 12,500. All right, there's multiplication in them thar hills. See it right there? There's multiplication. So the opposite of multiplication is to divide over. So when you divide this, you're going to discover quickly that you're going to get 2. So really what I'm asking is how long does it take for this town to double? Because this turning into that is double the amount. So that's what that tells us. Now we bay it up. Bay it up. So with base E, I use natural log because natural log is base E. So it's log base E, which is natural log of 2 is equal to the exponent, which is 0.03t. Again, there's multiplication in them thar hills, so it's this times t. So I have to divide over the 0.03. All right, so that gives me the t. And that's the exact answer. To t is equal to natural log of 2, 0.03. which is approximately equal to, and then we type it in, we say the number of years. So I go natural log of 2, close the parentheses, divided by 0.03, enter. So 23 years, 23.105 years, 23.105 years, okay? So there's the exact answer, there is the number of years. And that is it. Pacha.